Hello everyone, my name is Pradeep Loganathan and today we're talking about Knative. Knative is a CNCF incubating project. It was started by Google in 2018 and it's one of the fastest growing open source projects. It has seen massive contributions from the community and others such as VMware, IBM and many other organizations. Knative enables us to build serverless applications and event-driven applications on top of Kubernetes. It provides a simple and consistent layer for managing containers and functions on top of Kubernetes. Knative is primarily composed of two primary components, namely serving and eventing. The serving components enables us to deploy, upgrade, route, and scale containers and functions on top of Kubernetes. And the eventing components enable us to connect systems together. The primary area where Knative shines is in developer productivity. If you really look at a graph of developer productivity versus the effort required in terms of infrastructure management or DevOps, functions as a service is a much more faster way to get to production. Developer productivity is very high in the functions as a service systems, which is where Knative shines. On the other end of the spectrum, we have bare metal, where the DevOps effort as well as the infrastructure effort required to manage infrastructure and the DevOps platform is much more higher, but it does not necessarily mean higher levels of developer productivity. In fact, developer productivity is pretty low in a bare metal environment, and that is where Knative shines in enabling functions as a service and enabling higher developer productivity in the fast environment. Now, why is this so important in the Kubernetes world? In the Kubernetes world, a lot of organizations are moving to cloud native services and microservices architecture. And as part of developing microservices architectures, a lot of services being developed out there. For each and every service, a developer has to create, or maybe even a platform operator has to create a deployment YAML, a service YAML, the ingress manifest, load balancers, labels, selectors, and there's a lot of work and effort involved in tying up all of these things together in order to deploy a simple service. It's not a fast path to production. It's not an easier code to URL sort of service. The other aspects such as scaling and production related configuration are also very hard when it comes to Kubernetes services. Scaling in terms of production, in terms of efficient resource utilization is also a hard problem to solve and requires a lot of effort and time in terms of setting it up. Uh, in the serving component of Knative, it creates a Knative service. This Knative service manages routes and configuration. There could be multiple routes which are active at any point in time, and each route points to a revision. A revision is a snapshot of a service and a configuration at any point in time. There could be multiple snapshots of your service running parallelly, and you can also have multiple routes pointing to each of these revisions. The Knative serving component enables us to provide scaling, routing, and manage snapshots. Now, in order to install Knative, we need to initially install the Knative serving components. And once the Knative serving components have been installed, we need to install the Knative core components, which have a dependency on the serving components. Once the Knative components have been installed, we need to install an ingress. We can use any ingress. It could be Istio, it could be Contour, or it could be Courier. Courier is a simpler ingress to use, and it's well integrated into the Knative ecosystem. Once the ingress has been installed, we would then need to patch Knative to use the ingress that we have deployed. Once the installation is complete, you can see that in the Knative serving namespace, you would have a bunch of components running, such as the activators, the autoscalers, and others, etc. And the service would be running within these with the help of these components. Now let's look at how does a Knative service gets activated. Whenever an end user hits a specific endpoint where a Knative service is being hosted, this endpoint would then would pass it on to the activator. The activator is responsible for activating the autoscaler, and the autoscaler then transfers it further to the queue proxy, which is a sidecar container which runs along with your code, and finally your code gets called. Let's assume that your activation starts from zero, wherein you do not have any containers or pods running, in which case, whenever the endpoint is hit, the activator will hold on to that request. The autoscaler will scale the service, starts to create pods and containers so that your request can be worked upon. And once that's up and running, then the autoscaler will proxy traffic to the pod through the queue proxy. And once this is done, it also updates the endpoint to resolve to the pod's IPs because we already have pods up and running. We would see at a later point in time as part of the demo as to how we could scale from zero and how once you've scaled from zero and there are very less requests, it can also scale back to zero and this whole process starts all over again. So this in a nutshell is primarily about Knative's process as to how requests move from an endpoint to your code. In terms of the autoscaler, Knative can use different types of autoscalers. The primary autoscaler that Knative uses is the Knative pod autoscaler, which comes along with Knative. This is the default autoscaler for Knative. It's enabled by default and it's part of the serving components. The KPA provides a scale to zero functionality, and it does not scale based on CPU metrics. Rather, it scales based on request metrics and other factors. The other option is to use the horizontal pod autoscaler. The horizontal pod autoscaler requires custom configuration to be used by Knative. It does not provide the scale to zero functionality, and it is primarily based on CPU-based autoscaling. So this is Knative serving in a nutshell. We will look at more about Knative serving as part of the demo, where we deploy a service and we will scale it up and scale it down and see how Knative serving works. Okay, so let's get started on deploying a Knative service to a Kubernetes cluster. In this case, I'm using Kind. Kind allows you to run Kubernetes clusters locally. Kind uses Docker container nodes to create a Kubernetes cluster. So I'm creating a Kind cluster on my local development machine. This is the cluster configuration that I'm using. I'm using a custom cluster configuration purely because I'm performing two additional port mappings. I'm mapping the host port 80 to the container port 31080. I'm also mapping the host port at 443 to the container port at 31443. This basically allows mapping both the HTTP and the HTTPS endpoints. I'm using this mapping purely because I'm using Courier as an ingress, which we'll talk about at a later point through this installation. Courier is what we're using as an ingress over here. You can also use Istio or Contour, but Courier is an ideal ingress in case of local development. Let me just make sure that I'm pointing to the right Kubernetes cluster. Yes, my context is pointing to the right one. Now, we will be installing the serving components of Knative. Once I've installed the serving components of Knative, I'll just wait before they're up and running. Now we are installing the core components of Knative. Basically, Knative serving components are split into two parts. One is a serving components, and then there is a core components. And you basically generally install the serving components initially, and then the core components. The core components have a dependency on the serving components, and so the order of installation is critical. We need to wait for the serving core components to be up and running. It generally takes some time for the serving core components to come up. In my experience, it's much better to wait for the serving core components to be deployed and the pods to be up and running, because if you go forward with the next set of steps, it generally creates issues at a later point in time. Once the core components are installed, we would be installing Courier. Now, Courier is an ingress that you can use. Courier was initially part of 3Scale and it's right now part of Knative, and it's available in the GitHub repository of Knative in GitHub. Now that we have installed Courier, we'll just wait for the pods to be up and running within the Courier system. Once these pods are up and running, we then need to configure DNS. We'll just wait for some more time while the pods come up. DNS configuration is critical because the DNS configuration is essential to ensure that we have the necessary URLs to point into our Knative service. So what I'll be doing is that I'll be setting up a domain service using NIP. Okay, so now our Courier system is up and running. We'll just check the Knative serving components once. Yes, everything is up and running. We will create a variable to point to our local host. And what we are doing over here is to use the nip.io service. It's a wildcard DNS service for IP addresses. It allows you to map domain names with the .nip.io extension to your local host. It's an easy and powerful solution for generating domain names to map to a local app or a Kubernetes cluster, which is what we're doing right now. So let's set up the necessary variables and I'll check if the domain has been set. So our workloads would be running at this particular domain. Let me just check the A record. So what I'm basically looking at here is to ensure that the A record for 127.0.0.1.nip.io is pointing to my local host, which it is as confirmed by dig. Now that we have set up Courier as the ingress, or rather we've installed Courier as the ingress, and we have configured the necessary domain, we need to make sure that the config map for config domain is pointing to the domain that we need. So over here you can see that the domain has not been set. we need to patch it to ensure that it is set to the right domain. Now that it's patched, we can check that it's pointing to the necessary domain. So you can see over here, it's pointing to the domain that we previously set up, which is or rather to the URL that we previously set up, which is 127.0.0.1.nip.io. Once that is done, we need to configure Courier. Now, Courier is a lightweight alternative for Istio Ingress, as it only consists of an envoy proxy and a control plane for it. The Courier service is generally said to be of type load balancer. On local machines, just what I'm doing right now, installing it on a kind cluster. This particular type doesn't work. The load balancer doesn't work. It's only available in cloud providers. So what we need to do is to change it to a node port. And that's the reason why I have this Courier configuration YAML. Over here, I'm setting it to be of type node port, and I'm also configuring the node port and the target port based on the kind cluster configuration that we did previously. So let's go ahead and run so let's apply these changes. Once this has been done, let's ensure that the config network points to the right place. And yeah, okay, so the Ingress class has been set up over here to that's strange. Let me set it up properly. And then check again. Yeah, the Ingress class has been set up fine over here. Now that the Ingress class has been set up to Courier over here, let's ensure that all our pods are running. Sorry about that. And let's make sure that the rest of the pods are running here. Yeah, Courier is running, and yeah, the services are up and running. That's good. Okay. Now what we have done is we have installed Knative serving components and core components on a kind cluster. We have deployed Courier as our ingress, and we have also configured Courier correspondingly. We have configured DNS, and we have ensured that we have the right URL. We've used nip.io to ensure that there is proper loopback and pointing back to the URL that we needed. Everything has been set up for us to deploy our first Knative service. What I'm going to do is I'm going to use a Knative CLI to install the service. So I'm using kn, and I'm creating a service called hello. This service is using an image, which is the Hello World Go sample. This is a sample image which is already available as part of Knative samples, and I'm exposing it on port 8080, and it basically echoes whatever is set up in the environment variable target. So I'm creating this service, and when this service is created, basically what will happen right now is that the kind cluster will pull, or rather the Knative service running on kind cluster will pull down this image. It will configure the necessary containers. It will ensure that a service is created. It will ensure that the necessary routes are created, and the routes are pointing to the necessary revisions. So it will basically create revisions. The revision should be 00001, and it will also ensure that configurations are created. Now, as a developer, you do not have to worry about any of these factors. You do not worry about creating a service. You do not have to worry about creating a deployment. You do not worry about creating any of the other Kubernetes manifests. You only need to create a Knative service. And Knative ensures that it wires up all of them together. Uh, as an operator, you need not worry about things like, for example, scaling. You do not need to set up scaling factors. You can, because Knative ensures that it can scale the system up as there is more demand, and it can scale the system down when there is low demand. In fact, it can scale the system down to zero, as previously discussed. So now we have deployed our service. We'll just ensure that everything is up and running. So the service is up and running. we will get the service URL. In fact, when you create it using Knative CLI, you already get the service URL. So when I echo the service URL, it should be the same. So the service is available at this particular URL based on the DNS that we had set up earlier. Now what I'll do is I will place a watch on the pods. So I will go over here and I will watch for pods which are of type service hello. And what I'll now do is to call the service. And when I hit this particular endpoint, it comes back to me with a hello Knative, which means our service is up and running and it's working perfectly fine. So yay, we have deployed our first Knative service and the service is responding back. We have the service running within a Kubernetes cluster running locally, and it's being served using two particular pods. Now this service should terminate in some time if there are no more requests coming through. In fact, when I ran this previously, I could see that it ran for some time, and once there were no more requests, it started terminating the containers, and after some time, I again sort of had a couple more requests at this particular endpoint, and the containers were created again and they started running back again. Now that takes a couple of seconds to terminate the container. So either we can wait or we can sort of say, yep, it works, because we have seen that happening previously wherein it terminates. So yeah, you can see it happening over here. Now that there has been no requests coming to this endpoint for some time now, Knative has automatically terminated one of the containers, and you can now see there is only one running. And this is how you save up on resources, and you only ensure that workloads which have higher resource requirements or which are very busy get the necessary resources allocated automatically and dynamically. You can in fact even set rules to say under what conditions and how this scaling would happen. And you can also set minimum scaling conditions. You can see over here that since there have been no requests coming through for quite some time, the service has been terminated to 0. So there are 0 containers running right now with 0 resource requirements from your workload happening. Let us now try and scale the service. Now that it's terminated to 0, let's now see if we can scale the container again. So now that I'm calling the service, you can see that it created a container and it's now scaled up back to 2 pods that were running earlier. So this is Knative's scaling in action, wherein it can scale a service up as and when requests come in, and it can scale a service down by terminating the containers when there are no requests coming through. So this is Knative's magic, wherein it automatically scales up and down, and as an operator, you need not have to configure or worry about it. So what we have done right now is to deploy Knative onto a kind cluster running locally on my machine. We have deployed Courier, and we have configured Courier as the ingress. We have deployed a Knative service. We have scaled the Knative service based on requests coming through, and once the requests terminated, the the number of containers tapered off and it scaled down to 0. So thanks.